What is discontinuity? Discontinuity is when the graph breaks in the middle. Is when you are not able to draw the full graph without lifting the pencil of the paper, like in the example. There is a little gap between both graphs. There are many types of discontinuity, but in this video we're only going to talk about 4. Point discontinuity, infinite discontinuity, jump discontinuity, oscillating discontinuity. First, point discontinuity. Point discontinuity is also called a hole. A hole is seen in a graph when the value approaching is not defined. For example, the first example, f of x equals x squared minus 1 divided to x minus 1. If we equal the denominator to 0, we get that f of x is not defined at the value of x equals 1. So there is a hole in the graph in x equals 1. And in the second example, x squared times x minus 2 divided to x minus 2, if we equal the denominator to 0, we get that the function is not defined at x equals 2. So there's a hole there also. Infinite discontinuity, the rational function that has a vertical asymptote. F of x equals x divided to x minus 2 has a vertical asymptote in x equals 2. Because the function is not defined at x equals 2. And if we see in the graph will approach very close to x equals 2, but will never cross or touch x equals 2. As in the second example, f of x equals x plus 4 divided to x minus 1 times x plus 4 plus 8, we have two vertical asymptotes, x equals 1 and x equals minus 8. And we can see in the graph that the graph will always approach very closely to x equals 1 and x equals minus 8, but will never cross or touch x equals 1 and x equals minus 8. Jump discontinuity. It is also called a piecewise function. There are conditions in both functions. For example, in the first example, f of x equals x squared with the restriction of x equal or minus 1 and 6 minus x is greater than 1. And we see in the graph that there is a gap between both functions. That's jump discontinuity. And in the second function, f of x equals x plus 1 if x is less than 2 and minus 2 times x plus 7 if x is equal or greater than 2. Oscillating discontinuity can be removed and is not defined. It is an infinite discontinuity, as in the examples of f of x equals sine times 1 divided to x and f of x equals sine 1 divided to x squared.